When evaluating bolts, specifically grade 2 versus grade 5, there are several factors to consider. These include tensile strength, shear strength, corrosion resistance, and cost. Tensile strength refers to a bolt's ability to withstand pulling forces. Grade 5 bolts possess a higher tensile strength compared to grade 2 bolts. This makes them suitable for applications where connections experience considerable tension or vibration. Shear strength, on the other hand, indicates a bolt's capacity to resist forces applied perpendicularly to its axis. Both grade 2 and grade 5 bolts exhibit similar shear strength. Regarding corrosion resistance, grade 5 bolts, often made of alloy steel, generally offer better resistance than grade 2 bolts, which are typically made of carbon steel. Alloy steel's enhanced corrosion resistance is advantageous in outdoor or humid environments. Cost is another important consideration. Grade 2 bolts are usually less expensive than grade 5 bolts. The acceptability of grade 2 bolts for field connections hinges on the specific application and its load demands. If field connections are not subject to substantial loads or significant vibration, grade 2 bolts might suffice. However, if the equipment operates outdoors or in a corrosive setting, grade 5 bolts, with their superior corrosion resistance, are a better choice. Grade 5 bolts can provide improved long-term performance and greater reliability, which potentially reduces the frequency of maintenance. It's also important to note that certain industry standards or specifications may mandate the use of grade 5 bolts for specific connections. As a general recommendation, if field connections involve critical loads, vibration, or exposure to harsh environmental conditions, it's advisable to use grade 5 bolts. If the loads are minimal and the environment isn't corrosive, grade 2 bolts combined with lock washers may be a viable option. Consulting with the equipment manufacturer or a qualified engineer can help determine the appropriate bolt grade and washer type for a particular application. Finally, weigh the cost implications and maintenance requirements when making a final decision. In more detail, let's explore the properties of grade 2 and grade 5 bolts. Firstly, tensile strength is a critical factor in fastener selection. Grade 5 bolts typically exhibit a tensile strength of approximately 120,000 pounds per square inch, abbreviated as SI, while grade 2 bolts generally have a tensile strength around 60,000 SI. This difference means that a grade 5 bolt can withstand roughly twice the pulling force of a grade 2 bolt of the same size and thread. Secondly, shear strength is important when the bolt will be subjected to forces that try to cut or shear it. While the shear strength of grade 2 and grade 5 bolts is similar, it is still an important consideration in applications where shear forces are significant. Thirdly, corrosion resistance is a major consideration in environments where exposure to moisture or chemicals is likely. Grade 5 bolts often have a protective coating, such as zinc plating, to enhance their corrosion resistance. Grade 2 bolts may also have a coating, but the underlying carbon steel is more susceptible to rust if the coating is damaged. Fourthly, cost is always a factor in any engineering decision. Grade 2 bolts are generally less expensive than grade 5 bolts because they are made from less expensive materials and require less processing. However, the low cost of grade 2 bolts may be offset by the need for more frequent maintenance or replacement if they are used in demanding applications. When deciding whether to use grade 2 or grade 5 bolts in field connections, it is important to consider the specific requirements of the application. If the connections will be subjected to high tensile loads or significant vibration, grade 5 bolts are the better choice. If the connections will be exposed to a corrosive environment, grade 5 bolts with a protective coating are also recommended. However, if the connections will not be subjected to high loads or harsh environments, grade 2 bolts may be acceptable, especially if cost is a major concern. In addition to the factors mentioned above, it is also important to consider any applicable industry standards or specifications. Some standards may require the use of grade 5 bolts for certain types of connections, regardless of the specific load or environmental conditions. When in doubt, it is always best to consult with a qualified engineer to determine the appropriate bolt grade for a particular application. They can assess the specific requirements of the application and recommend the most suitable type of bolt. Furthermore, consider the use of washers. Washers serve several purposes in bolted connections. Flat washers distribute the load over a larger area, reducing stress on the bolted material. Lock washers prevent loosening of the bolt due to vibration or other dynamic forces. Belleville washers, also known as disc springs, provide a spring force that helps maintain tension in the bolt. When using grade 2 bolts, it is often recommended to use lock washers to help prevent loosening. Belleville washers can be particularly effective in applications where vibration is a concern. However, it is important to select the correct type and size of washer for the specific bolt and application. Using the wrong washer can actually reduce the effectiveness of the bolted connection. In summary, the choice between grade 2 and grade 5 bolts depends on a variety of factors, including tensile strength, shear strength, corrosion resistance, cost, and applicable industry standards. Grade 5 bolts offer higher tensile strength and better corrosion resistance, making them suitable for demanding applications. Grade 2 bolts are less expensive but may require more frequent maintenance or replacement. When selecting bolts for field connections, it is important to carefully consider the specific requirements of the application and consult with a qualified engineer if necessary. Always use appropriate washers to distribute the load and prevent loosening of the bolted connection. To further elaborate on the material composition of grade 2 and grade 5 bolts, grade 2 bolts are typically made from low or medium carbon steel. The specific grade of steel used can vary, but it generally conforms to ASTM A307, which is a standard specification for carbon steel bolts and studs with a tensile strength of 60,000 psi. Grade 5 bolts, on the other hand, are made from medium carbon alloy steel. The alloy composition typically includes elements such as manganese, chromium, and molybdenum, which enhance the strength and hardenability of the steel. Grade 5 bolts typically conform to ASTM 449 or SAE 429 grade 5, which specify a minimum tensile strength of 120,000 psi. The heat treatment process used in manufacturing grade 5 bolts is also more complex than that used for grade 2 bolts. Grade 5 bolts are typically quenched and tempered to achieve the desired strength and hardness. The quenching process involves rapidly cooling the steel from a high temperature, which hardens it. The tempering process involves reheating the steel to a lower temperature, which reduces its brittleness and improves its toughness. The higher strength and hardness of grade 5 bolts make them more resistant to deformation and failure under load. They are also less likely to stretch or creep over time, which can lead to loosening of the bolted connection. In addition to the material composition and heat treatment, the manufacturing process for grade 5 bolts is also more tightly controlled than that for grade 2 bolts. This ensures that the bolts meet the specified strength and dimensional requirements. Grade 5 bolts are typically subjected to more rigorous testing and inspection than grade 2 bolts to ensure their quality and reliability. When selecting bolts for critical applications, it is important to consider the quality control measures used in their manufacturing. Bolts that are manufactured to recognized industry standards and subjected to rigorous testing are more likely to perform as expected and provide a reliable connection. Another important consideration when selecting bolts is the thread type. Coarse threads are generally used for general-purpose applications, while fine threads are used for applications where higher clamping force or greater resistance to loosening is required. Fine threads have a smaller pitch than coarse threads, which means that they have more threads per inch. This provides a greater surface area for friction, which increases the clamping force and resistance to loosening. However, fine threads are also more susceptible to damage and require more care during installation. When using fine threads, it is important to ensure that the threads are properly lubricated to prevent galling or seizing. Galling is a form of wear that occurs when two metal surfaces slide against each other under high pressure, causing them to stick together. Seizing is a more severe form of galling that can result in the threads becoming permanently locked together. Lubricating the threads can help to prevent galling and seizing by reducing the friction between the metal surfaces. The choice between coarse and fine threads depends on the specific requirements of the application. If high clamping force or resistance to loosening is required, fine threads are the better choice. However, if the application is subject to vibration or shock, coarse threads may be more resistant to damage. It is also important to consider the material being bolted. Softer materials, such as aluminum or plastic, may be more susceptible to thread damage when using fine threads. In these cases, coarse threads may be a better choice. Ultimately, the selection of bolts for a particular application is a complex decision that requires careful consideration of a variety of factors. These factors include the load requirements, environmental conditions, material being bolted, and applicable industry standards. Consulting with a qualified engineer can help to ensure that the appropriate bolts are selected for the application. Furthermore, understanding the torque requirements for different bolt grades and sizes is also critical. Torque is a measure of the rotational force applied to a bolt during tightening. Applying the correct torque is essential to ensure that the bolt is properly tightened and that the bolted connection is able to withstand the applied loads. Under-torquing a bolt can result in a loose connection, which can lead to vibration, fatigue, and eventual failure. Over-torquing a bolt can result in stripping of the threads or breakage of the bolt. The recommended torque values for different bolt grades and sizes are typically specified in industry standards or by the bolt manufacturer. These values are based on the bolt's tensile strength, thread pitch, and friction coefficient. It is important to use a calibrated torque wrench to ensure that the correct torque is applied. A torque wrench is a specialized tool that measures the amount of torque being applied to a bolt. Calibrating the torque wrench regularly is essential to ensure that it is providing accurate readings. When tightening bolts, it is also important to follow a specific tightening pattern. This helps to distribute the load evenly across the bolted connection and prevent distortion of the components being joined. A common tightening pattern is to tighten the bolts in a star pattern, starting with the bolt in the center and working outwards. Each bolt should be tightened in multiple stages, gradually increasing the torque until the final torque value is reached. This helps to prevent the bolts from being overstressed and ensures that the connection is properly tightened. In addition to torque, it is also important to consider the bolt length. The bolt length should be sufficient to ensure that the threads are fully engaged in the nut. As a general rule, the bolt should extend at least one bolt diameter beyond the nut. However, it is also important to avoid using bolts that are too long, as this can result in the unthreaded portion of the bolt protruding from the nut. This can reduce the strength of the connection and create a safety hazard. When selecting bolt length, it is important to consider the thickness of the materials being joined, as well as the thickness of any washers or other components that are being used. It is also important to consider the type of nut being used. Different types of nuts have different thread depths, which can affect the required bolt length. Lock nuts, for example, typically require a longer bolt than standard nuts. In summary, selecting the appropriate bolts for a particular application requires careful consideration of a variety of factors, including bolt grade, thread type, torque requirements, and bolt length. Consulting with a qualified engineer can help to ensure that the appropriate bolts are selected and that the bolted connection is properly designed and installed. Lastly, ensure proper storage of bolts and fasteners. Proper storage is important to prevent corrosion and damage to fasteners. Fasteners should be stored in a dry, protected environment away from moisture and chemicals. It is also important to keep fasteners organized to prevent mixing of different grades and sizes. Using a well-organized storage system can help to ensure that the correct fasteners are readily available when needed. In conclusion, when considering whether Grade 2 fasteners are acceptable for field connections, remember the critical differences between them and Grade 5 fasteners. Think about the tensile strength requirements, the environment the connection will be in, and the potential for vibration. Consulting with the equipment manufacturer or a qualified engineer is essential for making the right choice.